Okay, so hey everyone. Yeah, I'm happy to be here again at ETH Prague. It's a really nice conference, not too big and focused on Ethereum's core values. We at Sourcify believe transparency and verifiability are at Ethereum's core values. And today I will talk about how Sourcify brings that to source code verification. But let me start with a forum post that my colleague came across this recently, and it's in the Open Zeppelin forum, and the users discuss about some ERCs done that. And they deployed an example contract on Gurley testnet. So the ERC gives some standard about solidity functionality. So I wanted to see the source code now of this contract. And when you click on this link, you see this now. This is because Gurley has been deprecated. So was the Explorer shut down? And the question now is, where are the contracts? Where can I see the source code of these contracts? The problem is the data was just on one database and it was shut down, so a part of Ethereum's history is gone actually. Yeah, you may say this is just a testnet, but actually the explorers of productive chains have been shut down recently too, like Arbitrum Nova or Scroll. So that's a problem. But actually, Ethereum has very strong verification culture. Like the community demands developers to open source their contracts, to publicize them, so security researchers can verify that the contract code does what it should. And yeah, the contract can't steal your money. That's why we do this. And it's good that we have this culture in Ethereum. But we're in a quite weird situation now. The contracts are open sourced through closed source verifiers and closed dataset. So it's quite contradictory. But let's step back for a moment and revisit what is source code verification. So when you deploy a contract on-chain, it's stored on-chain in bytecode. It's some concatenation of EVM opcodes, and when you see this, you don't know what it does. It's meant to be read by a machine, not by humans. So humans write in programming languages, such as Solidity and Viper. But now, how do we know, if I show you this contract in Solidity, that it belongs to the bytecode that I showed you before? For that, we need a mapping between the source code and the bytecode and store that somewhere. And that's what source code verification provides. Let's have a look at the verification process. So usually when a developer wants to verify a contract, he takes the source files, some Solidity files, as well as the compilation settings, the Solidity version, some other compiler settings, and sends these to a verification service. And then the verification service takes them and recompiles. Using the compiler, gets some recompiled bytecode out, and yeah, the verification service then does an on-chain call, takes the RPC and gets some on-chain bytecode out and simply checks if these match. And then we store the result in the database and make it publicly available. So it's a bit oversimplified here, but at its core, that's how source code verification works. So I said, like in the example before, you saw that there are problems. Let's have a look in detail what problems there are. The largest verification service is closed source. So you can't verify how the verification process itself works. There could be bugs, there could be intended misleading behavior. The verification process is just a black box. And yeah, that's a problem. There have been pretty bad bugs in the past, and that were only possible to identify by white hat hackers. Another problem is that it's centralized. As you saw in the beginning, it fails the walkaway test. When the service disappears, the protocol fails. These contracts on Gurley and Rinkepi are gone, and yeah, we lost part of Ethereum's history with that. Another problem is that the data set is closed. While on one hand, you can easily build an explorer because the data is on-chain, it should live forever on-chain, and you can just fetch it and build your own explorer with it. But the verified contract data is siloed and lives in a database, so you depend on the service's database. And yeah, the service gatekeeps it. You may have to pay money, you can't really download it in bulk. So the community doesn't have ownership of the data. And another problem we see is that the tooling stagnated for a while. Like there was an API that was developed years ago, and it hasn't been really developed further since then. For example, you need to provide API keys, constructor arguments, which are not even required for the verification process itself because you can just fetch them from chain. And yeah, that leads to suboptimal developer experience. And yeah, we also think there are a lot of interesting outputs that the compiler give, but yeah, they are simply not available by the current APIs. So yeah, the current players are not really incentivized to open up because it's a business model for them to close this data set. And Sourcify is here to change that. So what is Sourcify? Sourcify started a few years ago within the Ethereum Foundation as a side project of the Solidity compiler team. And last year we spun out with the Solidity compiler team and a few other teams into a new organization called the Argo Collective. So the Argo Collective is non-profit, we don't generate any revenue, and yeah, we were seeded by a Ethereum Foundation grant, and yeah, live with grants at the moment. So Sourcify is a small team, we're just developers, it's Marco, Khan, and me. So I talked about problems. Let's see what Sourcify offers, what kind of solutions there are. First of all of our components are open source, of course. Our core verification logic lives in a TypeScript library. You can just fetch it from NPM and run it yourself. And you can see the source code. So you can review how it works. You can find bugs. You can maybe shoot a PR if you see room for improvement. And yeah, that's pretty good. Because that enables also self-verification. So you can reproduce the verification result. You don't have to trust us that we just claim that the source code and the bytecode match. You can take the verification logic and rerun that. We have an example for that. So Otterscan is a local first block explorer, and it integrates Sourcify. So when you visit a contract page of Otterscan, then you can click a little button and fetch the sources from Sourcify. It then locally runs inside your browser our verification logic, recompiles and checks that the bytecodes match with the source code. So you can reproduce the verification result. Open source also enables self-hosted Sourcify instances, so we don't want to be the only source of truth. So we're happy when others also run Sourcify servers. There are a few chains and security companies which have their own Sourcify instances. These 6 are the ones we know of currently. Maybe there are even more we're not aware of. But yeah, it's good that they are able to run these. One paradigm that Sourcify fosters pretty heavily currently is verify everywhere. That means we want to reproduce the verification data not only in our database, but everywhere, like on other verifiers. So we don't want that when we are gone, the data is gone. So for this, we founded one initiative called the Verifier Alliance. It's an initiative by BlockScout, RouteScan, and us. And yeah, we aim to be an open standard for the verification data. And it works like that. When you verify a contract on any of these 3 verification services, the result is not stored only on their own databases. We also write the result into a shared Postgres database, which is then made publicly available. So anyone can access the data. Next is, we also want to replicate the data on the databases of the other verification services themselves. So we have two mechanisms for that. When you verify on Sourcify, the Sourcify server also sends a verification request to Etherscan, RouteScan, and BlockScout, so they can run their own verification pipeline and store the result in their databases. So it goes also to their places. And we have another mechanism for that, and that is via the tooling directly. So one step ahead, we push the tooling into the direction that they not only send the verification request to one place, but instead to like all verification services. For that, we implemented a Remix plugin, which became the default now. So when you verify on Remix, if you don't disable any of the verifiers, verification request just goes to all of these places. We have the same for Hardhat, and yeah, Foundry we still have to push, but we are in contact with them. Another principle of Sourcify is open data. We have 28.5 million verified contracts across 190 chains, and make this complete data set freely available to anyone, for anyone to access it. There are multiple ways to access it. You can just fetch the source code from a single contract via the API. We also, but that just works for single contracts and not so much for bulk access. For bulk access, we provide a full database dump in a modern format called Parquet. And yeah, we export all columns of our database into this Parquet format daily and upload it for people to download it. So this exists for Sourcify and for the Verifier lines. What we also do is we push our complete data set to BigQuery, so you can use the Google's platform for data analytics directly. And this is actually updated live while contracts are verified in Sourcify. And yeah, open data also enables us now to run other services. We run a 4-byte service today. A 4-byte service is like a lookup service for the 4-byte function selector via the function signatures and vice versa. So there was openchain.xyz, which we have taken over last year. We imported the database, implemented the same API, and yeah, this is currently used by tooling internally, like Foundry uses for the transaction decoding. So you might not even notice that you use this, and yeah, already use it. So it's actually our service is now the biggest 4-byte service in the ecosystem. And the nice thing is, it's also powered by the verified contract data now. So when a verification goes into Sourcify, we also write the signatures and selectors into the 4-byte database. What Sourcify also aims to provide is better tooling. Just to name a few, so we try to make almost all compiler outputs accessible. We think it's useful to also have storage layouts and source map, and hope people can use it for useful for their tooling. We have metadata JSON support. I don't want to get into detail, but if you use the metadata hash, which is appended to Solidity bytecodes, you basically get cryptographic guarantees about a verification, and we are actually the only verifier that makes use of this cryptographic guarantees in the verification. We also have broad compiler support. We recently got support for Solidity from version 0.1.3, and that enabled a project called Ethereum History to verify contracts from the very early days of Ethereum, from 2015, I think. They were only able to verify these on Sourcify because, like other verifiers, simply don't support such old Solidity versions. We also support all Viper versions, and we got recently support for Felang, which is a new contract language, also developed by the Argo Collective. So yeah, that's what Sourcify has today. And now I want to give you a call to use this data set to move EVM tooling forward. We think it's very valuable to have this data set open and publicly accessible and free for everyone. So we are happy when people build stuff with it. So I think we are thinking of security pattern detection, training AI models, building a better decompiler, or whatever you can think of. So if you have a use case and need help in the process, we are always happy to help. Yeah, so that's what Sourcify does today. And now I want to give a short outlook what other initiatives we support for transparency and verifiability. That is namely the clear signing. That's a Ethereum Foundation-led initiative, basically to get rid of the blind signing. Blind signing is that. So when you sign a transaction within your wallet today, you usually just see some call data hex string and don't know really what it does. And that's a problem. So we want to go from this to this. You should see the clear intent in your wallet when you sign a transaction. And for that, we, like the working group, developed an ERC. The ERC was initially written by Ledger and refined in the last half year within the working group. The working group, by the way, consists of a few wallet companies, security companies. It includes Ledger, Trezor, and yeah, more. And yeah, Sourcify contributed by building a library for that and a small playground. And yeah, the ERC is pretty ready now, and we are now in the phase to go actively to wallets to support this. Yeah, if you want to try it out, you can try out the Sourcify playground for clear signing. And if you build a wallet, just reach out to us so we can keep you in the loop about this. That's it from my side. Thank you for listening. Here you can follow Sourcify and Verify Alliance on X. And yeah, do we have time for questions?
Yes, we do.
Okay.
Okay, so if anyone has questions, feel free to ask the speaker now.
Yeah. Okay.
Okay, if there's no questions and you'll get them later, you can reach out to Manuel and he will be happy to answer them, I believe, right?
Yeah, I will.
Okay, thank you so much for your speech.
Thank you.
Have a great day.